All right. Hi, everybody. We are on day 30. We're really close. This is where the year or the unit kind of gets intense. And so I just wanted to give you a little warning that, yeah, this is a little bit challenging. It's a little bit abstract. I'll try to make it as clear as I can for you, but please make sure that you're emailing me. Please make sure that you're asking questions. Please make sure that you're doing what you need to do so that you get this because it's sort of critical. Here we go. We're working on learning target 5B today, which is finding quotients and remainders of polynomial division problems. We'll jump into sort of the nuts and bolts of how to do polynomial division, and then we'll talk about a little bit later how to interpret a remainder. Okay, so I'm going to start with a review on multiplying polynomials just because division is the opposite of multiplication. And so we have to know where the multiplication comes from, how that works to be able to work with division. So let's do this multiplication. What I'm going to do is I'm going to use the box method. I'm comfortable with the box method. You all are also. So I'm going to rewrite the top. Whoops, -1. Sorry, -1. There we go. And then on the left side of the box, I'm going to put x minus 3. So then I suppose I should have a rectangle here. Got one there, there, and there. And I've got this. Okay, so I'll try to color code this as much as possible. So 3x cubed times x is 3x to the 4th. Negative 2x squared times x is negative 2x cubed. 15x times x is 15x squared. And then negative 1 times x is negative x. 3x cubed times negative 3 is negative 9x cubed. Negative 2x squared times negative 3 is 6x squared. 15x times negative 3 is negative 45x squared. Just kidding, it's not squared. Sorry about that. And then negative 1 times negative 3 is 3. Okay, so now I need to combine the like terms, and I'm lucky I have it color-coded for myself, so I have 3x to the 4th minus 11x cubed plus 21x squareds minus 46x's plus 3. So this is the product of these two multiplied together. Okay, so this is the product. All right, so that's multiplication. What we're essentially doing today is unmultiplying, right? That's what dividing is undoing multiplication. So that's sort of the rundown. I will talk a little bit more about what this looks like because it's a little bit tricky when you get to division. The reason that we're doing all this division stuff is, just like we said last unit, is if we can get our polynomials to look like a linear term times a linear term times a quadratic, or maybe there's one linear term or 3 linear terms, depends on what you have, depends on the degree of the polynomial. Then you can use the zero product property and chapter 4 stuff to solve the equations. So that's what our goal is today. Okay, so I just wanted to review one more time the factor theorem, which says that if you have a solution to an equation that says polynomial equals 0, then you can rewrite it with a factor. So you can say, hey, look, I know x equals negative 4 is a solution to the equation p of x equals 0. So p of negative 4 equals 0. And if you don't believe me, you can put it in for x here. You can put in negative 4 and you should get 0 out. Okay, so what we know is p of negative 4 is 0. And what that says is x equals negative 4 is a solution to the equation p of x equals 0. So what we can conclude is then x minus negative 4 is a factor of p of x. Okay, so what that means is, and by the way, I could rewrite this p of x, I could rewrite this thing right here, x minus -4, as x plus 4. That's fine. What that means is you can rewrite p of x as x plus 4 times something else. The something else is the thing that we need to figure out. But now this starts to look like one of those multiplication problems that we just finished. And so if we can use our sort of multiplication process only sort of backwards, then we can figure out what goes in this scribble right here. What does all of this mean? Well, like we said on the last slide, we know that p of x looks like this, and we know that x plus 4 is a factor of p of x. So we must be able to rewrite p of x as x plus 4 times some other polynomial. The thing that we have to do then is we have to be able to figure out what that other polynomial is. And so what we're going to do is we're going to say, you know what, we know x plus 4 times some other polynomial gives you p of x. And so what we're going to do is we're going to create a box method multiplication where our p of x is inside the box and we're finding this other polynomial. Okay, I'm going to do that on the next slide. So what I'm trying to do is I'm trying to divide p of x into x plus 4 times something else up here. So I'm going to put my x plus 4 here. And normally when we're using box method, we would just kind of split this up into some boxes. And I'll do that here too. I don't know exactly how many boxes I'm going to need, but I'm going to find out. When we do the multiplication, you maybe have noticed that I've kind of been working with this color coding strategy like this. And so somehow our x to the 4th has to be in the black, 2x cubed has to be red, negative 10x squared has to be blue, negative 4x has to be green, and then the 16 has to be yellow. So I'm going to start with the x to the 4th. I know that I'm going to have an x to the 4th in that box because it's the only thing that could possibly multiply to x to the 4th, which means that I have to put a x cubed here. This is a little bit like factoring where you're figuring out what goes on the outside of the box. So if I have an x cubed here, if this has to be x cubed, then x cubed times 4 has to give you 4x cubed. But I don't want 4x cubed, I want 2x cubed. So between these two boxes, I need to get 2x cubed. So I'm going to take away 2x cubed. I'm going to subtract 2x cubed because these two in the red circles add now to this 2x cubed. I'm being a little bit creative about what I'm using, what I'm choosing to add or subtract. But remember that what I'm representing in here inside the black box has to give me p of x. So together, these two terms have to give me positive 2x cubed. Now I can proceed. I can say, you know what? Now that I know that this is negative 2x cubed, then I have to conclude that this has to be negative 2x squared. Why is it negative 2x squared? Because this times this has to give you negative 2x cubed. Okay, I'm okay with what I have on the top of the box now, but now what I have to figure out is if I have negative 2x cubed here, then what do I need to put here? And so my result is going to be whatever negative 2x cubed times 4 is, which is negative 8x cubed. Okay. But here's the problem. I don't want just negative 8x. I'm sorry, I made a mistake. It should be x squared. Sorry about that. I don't want just negative 8x squared. I want negative 10x squared. So how do I get there? What am I missing? I'm missing another negative 2x squareds because these two together give me my goal, which is negative 10x squared. So then I must have to write negative 2x here because my negative 2x times my x gives me this negative 2x squared. So now I need to continue. I need to say, okay, negative 2x times 4 gives me negative 8x. But I don't want negative 8x. Between these two, I need to add to negative 4x. So what am I missing? I'm missing 4 x's because these two together have to add to this, and now they do. So then I need to choose what I put on the top of the box. And this is going to be a 4. It's 4 because 4 times x gives you 4x. So then 4 times 4 is 16. And now we're done. And the reason I know we're done is because this matches this. And that means that I came out even, and that means that I did my division correctly. So make sure that this bottom right box matches this right here. If it doesn't, you're not done yet. So then, what am I left with? I can say two things. I can say that p of x is, x to the fourth plus 2x cubed minus 10x squared minus 4x plus 16. I can say that, that's fine. I can also say that p of x is x plus 4 times the other polynomial. And the other polynomial that I have now is x cubed minus 2x squared minus 2x plus 4. And I got that from the top of the box. So what I did was I divided this polynomial p of x by x plus 4. That allows me to figure out what the quotient is, the answer to the division problem right here. And then that allows me to rewrite my polynomial as a factor times another polynomial. The other thing that I can just say is, hey, you know what? P of x divided by x plus 4 is equal to x cubed minus 2x squared minus 2x plus 4. The useful piece of information here is that p of x is equal to this times this.